In this video, we are going to talk about double bond equivalence. Double bond equivalence is also known as the unsaturation index. And then it is also known as index of hydrogen deficiency. So the unsaturated index is abbreviated as UI, or index of hydrogen deficiency. Now, what is double bond equivalence? It is the number of unsaturation in a molecule. And unsaturation in a molecule means either a double bond or a ring. For example, if you take this, you see that this is 1 butene. 1 butene has one double bond, and for that matter, it has one double bond equivalence. Because if you compare one butene to the normal butane, so let's do the comparison. This is a proton, this is a proton, this is another proton. There are two protons here. There's one proton here, and then there are two protons here. So if you count the total number of protons, you see that there are 9. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, there are 8. So this is C4H8. However, if it was to be the corresponding alkane, then it would have been C4H10. Comparing this molecule to the corresponding alkane, this molecule is short of 2 protons, and those 2 protons make up for the double bond, and therefore it has one double bond equivalence. So let's consider cyclopropane. You see that cyclopropane has 6 protons. And let's consider the normal propane. The normal propane has 8 protons. There is a deficiency of 2 protons here, and it is those 2 protons that make up the ring, and therefore cyclopropane has one double bond equivalence. Let's consider pentane. So pentane is C5H12. However, if you consider cyclopentane, you see that cyclopentane is C5H10, and therefore cyclopentane also has one double bond equivalence. Now let's consider butane. You see that butane has what? 2 double bond equivalents. So if you see a triple bond has 2 double bond equivalents. Then if you see a double bond has 1 double bond equivalence. And if you see a ring has 1 double bond equivalence. However, if you see a ring and then a double bond, this is 2 double bond equivalents. And then if you also see 2 rings that has been fused together, for example, this. So this molecule has 2 double bond equivalents because there's one double bond that makes up this ring, and then the second double bond makes up this one. Okay, so now your turn. You can pause this video and solve this question. How many double bond equivalents does benzene has? So you see that benzene has 1 ring. So it has 1 ring. And then it also has 3 double bonds. And because benzene has 1 ring and 3 double bonds, it is 1 plus 3, which will make it 4 double bond equivalents. And therefore, benzene has 4 double bond equivalents. How many double bond equivalents are there in the molecule above? This is molecule A and this is molecule B. So let's consider molecule A. You see that molecule A has one double bond. And then apart from one double bond, it also has one triple bond. One triple bond. So the one double bond has one double bond equivalent, and then one triple bond has two double bond equivalents. So 1 plus 2 will give us 3. And then aside that, you also have this double bond here, which makes it 4. And then there are 4 rings, so 5, 6, 7, 8. And then apart from that, it has 3 pi bonds in 2 rings. So this ring has 3 pi bonds. This ring also has 3 pi bonds. So it makes it 6 pi bonds. So 6 pi bonds plus 8 that we got initially, that will give us 14 double bond equivalents. So this molecule has 14 double bond equivalents. They are this ring, that's 1, 2, 3, 4, 4 rings, then 5, 6, then 7, 8, then plus the 3 pi bonds in each of this ring, which makes it 14. Let's come to this molecule. How many double bond equivalents does this molecule have? It has 2 rings, that is 2 double bond equivalents, plus this double bond, that makes it 3, plus this 4, plus this one 5, plus this 6, and therefore this molecule has 6 double bond equivalents. For double bond equivalence, it's giving us 2C plus 2 plus N, where N is the number of nitrogen, minus H, where H is the number of hydrogen, minus X, all divided by 2. And X stands for the halogens. So therefore, what is the double bond equivalence using if we are given C6H6? So in this case, DBE is equal to 2 times the number of carbons, and the number of carbons here is 6, plus 2. Then there are no nitrogen, so nitrogen is 0, minus the number of hydrogens, which are 6. Then there are no halogens, so the halogens portion is also 0. All of that divided by 2. So this is equal to 2 times 6 is 12. 12 plus 2 is 14. 14 minus 6 is 8. 8 divided by 2 is 4. And therefore C6H6 has 4 double bond equivalent. But what is C6H6? It is the benzene. And remember that we've already established that benzene has a double bond equivalence of 4. Now, what if we were given cholesterol? Cholesterol has a chemical formula of C27, H46, and O. What is the double bond equivalence of cholesterol? So DBE is equal to, using the same formula, 2 times the number of carbons, which is 27, then plus 2, then plus nitrogen. Nitrogens are not in this compound, so it's 0. Then minus the number of protons, which is 46. Then minus the halogens. This formula does not have halogens, so it's 0 divided by 2. 2 times 27 is 54. 54 plus 2 is 56. So we are going to get 56 minus 46 divided by 2. And this is equal to 10 divided by 2, which is equal to 5. And therefore, the number of double bond equivalents in cholesterol is 5. Let's also calculate the number of double bond equivalents in cortisone. Cortisone has a molecular formula of C21, H28, and then O5. So the double bond equivalence using the same formula is equal to 2 times the number of carbons, and in this case is 21, plus 2, then minus the number of nitrogen is not in this molecule, so it's 0. And then there are no halogens too, so that portion is also 0. Then the oxygen does not feature in the formula, and therefore that is also 0. So we are going to just subtract it from, we are going to subtract 28 from it, divided by 2. So 2 times 21 is 42. 42 plus 2 is 44. 44 minus 28 divided by 2 will give you 8 double bond equivalents. And therefore, cortisone has a double bond equivalence of 8. Now, let's come to DDT. DDT has a molecular formula of C14H9 and then Cl5. What is the double bond equivalence of DDT? So DBE is equal to 2 times the number of carbons, which is 2 times 14, plus 2, plus the number of nitrogens. Nitrogens is 0 here. And then the halogens, minus the number of hydrogens. So minus 9, because there are 9 protons. And then the halogens, which is X, is 5, because chlorine is a halogen, so minus 5. All of that divided by 2. So 2 times 14 is 28. 28 plus 2 is 30. So 30 minus 9 minus 9 minus 5 is 14 divided by 2. And this is equal to 8. So DDT also has a double bond equivalence of 8. Now let's talk about caffeine. Caffeine has a molecular formula of C8H10N4O2. What is the double bond equivalence in caffeine? So DBE is equal to 2 times the number of carbons, and in this case is 8, plus 2. Then the number of nitrogens are 4, so plus 4. Oxygen does not come in, because as for oxygen is 0, so it's 0 divided by 2. This is equal to 2 times 2 is 2 times 8 is 16. 16 plus 2 is 18. 18 plus 4 is 22. Sorry, I forgot something. Minus the number of protons, which is 10. So 22 minus 10 is 12. 12 divided by 2 will give 6. And therefore, caffeine has a double bond equivalence of 6. What is the double bond equivalence in this molecule? So you see that there are 2 pi bonds. Because there are 2 pi bonds, this molecule has a double bond of equivalence of 2. So 2 double bond equivalents. What about this molecule? And then you see that this is a terminal alkyne. So there are 2 double bonds in this molecule. It also has 2 double bond equivalents. What is the double bond equivalence in this molecule? So you see that this molecule has 1 ring and then 3 pi bonds. So therefore, this molecule has 4 double bond equivalents. How many double bond equivalents are in this molecule? You see that there is 1 ring and then 3 pi bonds. So it has 4 double bond equivalents. Nonetheless, there is 3 NO2s here. There are 3 NO2 groups that are attached to the molecule. Now, this NO2 is of this form. It is doubly bonded to oxygen. And then this is how the NO2 is bonded to this molecule. So you see that there is 1 double bond equivalence with reference to one of the oxygens. And since there are 3, there are additional 3 double bond equivalents. So if we add it to the previous 4, it's going to be 7. And therefore, this molecule has 7 double bond equivalents. Deduce the double bond equivalent of the following: A, C3H4Cl-Br. So let's start with A. The A is C3H4Cl-Br. Remember that we say that the double bond equivalence is given as 2C plus 2 plus N minus H minus X divided by 2. So in this case, there are 3 carbons, so 2 times 3 plus 2. There are no nitrogen, so it's 0. But there are 2 halogens, chlorine and then bromine. So it becomes minus 2. Then the number of protons are 4, so minus 4. All of this divided by 2. So plus 2 minus 2 can cancel out. 2 times 3 is 6. 6 minus 4 is 2. 2 divided by 2 is 1. And therefore, this molecule has 1 double bond equivalent. Let's come to the B. The B is C4H5OCl. So DBE is equal to 2 times the number of carbons, and there are 4 carbons, and then plus 2. And then there are 5 protons, so minus 5. Then oxygen is 0. Then chlorine is a halogen, so minus 1 divided by 2. This is equal to 2 times 4 is 8. 8 plus 2 is 10. 10 minus 5 is 5. 5 minus 1 is 4. 4 divided by 2 is 2. And therefore, this has a double bond equivalence of 2. And then C. C is C5H8NOBr. What is the double bond equivalence in this molecule? So using the formula, 2 times 5 carbons, then there are 8 protons, so minus 8. Then there is 1 nitrogen, so plus 1. Oxygen is 0. Then there is a 1 bromine, so minus 1 divided by 2. So plus 1 minus 1 can go away. 2 times 5 is 10. 10 minus 8 is 2. 2 divided by 2 is 1. And therefore, this molecule has... Sorry, I made a mistake because the formula says plus 2. So we need to add 2 here. And therefore, this is 10 minus 8 is 2. Then 2 plus 2 is 4. 4 divided by 2 is 2. So this molecule has a 2 double bond equivalent. Now let's come to D. D is C6H10S. So the double bond equivalent is equal to 2 times the number of carbons are 6, so times 6, then plus 2 minus the number of protons, 10. Sulfur is 0, so divided by 2. And this is equal to 2 times 6 is 12. 12 plus 2 is 14. 14 minus 10 is 4. 4 divided by 2 is 2. Therefore, this molecule has a 2 double bond equivalence. Then let's come to the last one. The last one is the E, which is C6Cl6. So the double bond equivalence is equal to 2 times the number of carbons, in this case 6, plus 2, then minus the number of halogens, which is X, and that is 6 chlorine, so minus 6, divided by 2. So 2 times 2 is 2 times 6 is 12. 12 plus 2 is 14. 14 minus 6 is 8. And 8 divided by 2 is 4. So this is equal to 4 double bond equivalence.